Thank you. It's a real pleasure for me to be here, and I have to thank the organizer for inviting me. I must confess that when I received the invitation by Michael Neumeyer, I was really pleased to be chosen as the Italian in this group and being one of the few speakers that were involved in both in the first and the second EFLM conference. But then when I looked at the topic, I was really preoccupied, and it was a really difficult task. And so I asked some help from some friends also to see what to say about this. And well, then now I'm being the last speaker of this long day is even more difficult. But okay, so the first question was for me, which is the classical role of the clinical laboratory? And so I went back to a quite old paper that my father wrote in 1972 for the opening ceremony of the second Congress of CBIOC. And these are the role that were designed there. So to provide information for the clinician to help in diagnosing, treating, and monitoring diseases. This is very hospital setting. And this moved in the last few years to well-being monitoring, screening, and disease susceptibility. So today, the lab can be defined as the nerve center of diagnostic medicine. But there were also other things in that paper, and so the lab was considered a central place where most of the clinical requests converge and from where the answers originate. And then it was expressed in different words as a place for transitional research and meta-validation and consultation. So the symbol for that Congress was a microchip. It was in 1972, and the microchip as the symbol of the automation coming into the lab, but also as a place where all this information comes and from where the information come out, but also these are the clinical laboratory, the unit where the progresses of the basic science converge, are elaborated and used for the technological and organizational evolution of the diagnostic activity. So what we call now translational research. And so this is something that I consider something that is part of the classical role of the clinical lab. And this is part of the evolution of the laboratory. The lab started at the clinic, close to the patient. Then it was developed inside the clinical ward from simple tests operated by the physicians themselves to become what is now or is central laboratories. The question is, it will evolve to lab on a chip and come again outside of the central lab in the world. So using some figure that Mario Plebani published is the Giambattista Vico recurring cycles in coming from outside to inside and then outside again. So the question that is already said from Eric Topol, yes, he told a few years ago that the laboratory medicine will undergo the biggest shakeup in its history over the next decade, from central laboratories to mobile laboratories owned by and operated by consumers. I'm really skeptical that this will happen in the next few years, but the idea is if we have something that is really automated and near to the patient, and the data can go to smartphones, and or portals when there is some artificial intelligence, and what is the role of the lab. This type of science fiction situation, as also this morning Larry Kritschka nominated the famous tricorder of Star Trek saga, is really something that will happen shortly. We are a little bit scared of this possibility. In my opinion, no, for several reasons. And now the reasons are listed here. The quality of the existing big data. Problems in different technologies, standardization, units, reference intervals are to be solved before they can really be used efficiently. The high quality point of care system, now there are many, but it's difficult to imagine that some can merit for all the tests. The costs related to point of care, and last but not least, the ethical problems that also emerged this afternoon related to the direct-to-consumer practice and how to use it's really useful to have this in the future. So going through quite quickly through these problems, the problems related to big data, obviously nomenclature, units of measurement, they can be quite easily solved by computers, but you have to take care of that. This is the most important problem, is the analytical quality that is to be developed more, and related to this also reference intervals. Just relating to the problem of unit of measurement, don't forget what happened a few years ago. In 1999, this spacecraft crashed when landing or trying to land on Mars, because two different groups made the calculation with different units, one in one place and one in the other, and used metric units, SI units, and traditional units. And this made a mistake in orbit, and so it crashed. And this is the situation of units of measurement in Europe. This was not an objective survey, but just I asked the national representatives, but you can see that Southern Europe is still more on conventional units, while Northern Europe is more on almost always on SI or amount of substance units, and Germany is in between, at least from our survey. And the problem, going to the analytical problem, just one example from the wonderful work that Linda Tiempont did on harmonization of TSH measurement. This is the, This is the situation before and then after the harmonization towards the old procedure trimmed mean. These are 100 samples from patient measured with 14 different methods. You can see that the harmonization resulted in increasing the comparability among systems, but significant number of individual samples remain outside, and this may create problems. We need to improve the technologies to improve the comparability of results. And then going to the post-analytical part, just staying on TSH, the reference intervals. You can see these are the reference intervals from 14 different companies, and numbers goes on the, just looking at the upper limit from more or less around 3 to 5.6. So almost 100% different between different reference intervals. And is this justified by the technology? Maybe yes, maybe not. The problem is also that when you use the same technology, same type of tests, but the lab apply different reference interval. This is just a survey in Italy on some enzyme, looking at alanine aminotransferase, for example. Laboratories working with this method apply upper limits from less than 40 to higher than 60. So this creates confusion because it's not only difference related to the method, like for alkaline phosphatase, the one method have an upper limit around 120 and the other one around 300. So you must know that this is with one method, this is with another one. So before putting all the data together, and also the idea that of zeta log for unifying thing, I don't know if it will work properly for everything. And so this is another point that the different labs use different reference for defining reference interval. This is just a survey we did asking labs which kind of source for their reference interval, and as you can see, more or less for everything, they use essentially the higher percentage of labs declares to use reagents manufactured packaging inserts or scientific literature. Very few, probably less than this, internal studies, and other means pathology harmony initiative or Croatian national initiative for reference intervals. So this adds problems to problems. We want to normalize the results using the reference intervals is probably not a good idea. So going to the point of care technology, okay, we have now a lot of tests that can be done on point of care, but we need several different devices to do this. And also we have some problem of cost, according to which were in this paper on ClinCam, highly efficient centralized laboratory will have a cost cost-benefit ratio that will never be reached by point of care systems, and this is not a secondary issue in a situation where we all know the problems of cost and the resources for healthcare is limited. And finally, some consideration about the ethical question. I repeat something that was already told this afternoon. There is the problem of over-testing, because if some company wants to sell their products to the public, to the customers, and it will induce an increasing testing. And this, in a situation where there is a low prevalence of disease, may produce several false positives. This will create the need for or referring to the clinician and possibly to even invasive follow-up. So this is a situation that has to be regulated very, very strictly and with large attention. And finally, the problem of misinterpretation. This can be solved by artificial intelligence, but in at least now is really problematic and can create anxiety for the people, but also false reassurance if the results is considered normal, why it is not, and so the disease can be not treated or not identified properly. The problem is in which point of this curve are we? This is a paper from on precision medicine, and these authors tell that we are beyond the inflection point, so the situation will change very rapidly. I really don't know. We heard a lot of things this afternoon or this morning that are in favor of this idea that we are in a situation where we will change rapidly, but also there are many other things that are not in favor. So it's difficult to say how will happen in the near future. So I have try to say something about classical roles more than the profession and then on the clinical laboratory. So production, quality, development to translational medicine, validation of technology, advice, validation, interpretation algorithms, and control and supervise the functionality. Just to say something about each of these 7 points. Large production, why I think that it will stay in the lab at least for a number of years. There is a trend of centralization. This is a consolidation, and this will absolutely continue. And if we will see some real disruptive technology that could move outside the lab most of the tests, but I don't see it in near future, because also the high efficiency, the low cost, and the easy transfer of data now with the informatics, and a patient can access their results very rapidly. And also the drones were already nominating today. This is not a reality now, but may become a reality in the near future, and this will reduce the pre-analytical problem favoring the concentration. I believe that point of care will develop, and especially for some tests like infectious disease or control of chronic diseases, therapeutic drug monitoring will move part of the test outside the lab, but the large production will stay for a certain time. I believe not tomorrow. We'll see the situation where everything will move outside the lab. Going through the quality, we have the need of working together with industry, with international organizations like EFLM, IFCC, EQUAS organizer, to assure the comparability of tests between labs and in time, because we have seen that it's very important to follow the time trend. If we continue to change methods, to change technologies, to have different results, it is almost impossible to follow the patient during time. And so we're starting from the definition of the acceptable quality. We heard from Sverre Sandberg that we have this is one of the ideas from the first strategic conference, and we are working on this from standardization and harmonization of the analytical phases and the pre and post analytical phases. And this is the temple of standardization that was designed by Braga and Panteghini some years ago, and we have to work to make all the columns really working before to allow a real what we call precision or personalized medicine to evolve and to develop properly. And the role on translational medicine, I believe that part of the or most of the technology that was described today, for example, for the circulating cell-free DNA or for circulating cancer tumor cells, but all the molecular biology related to genetics, epigenetics, pharmacogenetics, and are now in between research and routine or clinical diagnosis. I believe that this will become part of the lab work, working on detection of microRNA, exosome, microbiome, and in different districts. Now, this is halfway is more research, but I think it will become reality as diagnostic practice. Mass spectrometry now is applied to some part of the lab, but will probably proteomics were more promising some years ago, but now I think that will come again important, and metabolomics and also biochemical and NMR. So these are parts that now as more research, I believe that in the future they should become part of our regular practice. And validation, this is very important topic because as Eugene Chan said in the same paper on disruptive technologies, the technology have to be validated, and disruption in laboratory medicine needs to pass this critical step. And the lesson we learned from Theranos is a very important lesson. We have to do this role of validating the new technology and enter into the market. Just to mention the problem of Theranos, the very sad story. I have to say that it was a journalist, and on the profession has some reaction, but not so big as could be expected. All of us reading about this fantastic technology was surprised that what can be done, how can be done. But now she is charged from 20 years jail for a number of problematic results released to patients. I don't know if this was just a failure of an idea and that they tried to do something to stay on the market, or it was just since the beginning a fraud. But this is something that should not be repeated in the future. We have to play this role of validation. And then probably we have to increase what is already something that we do, but the advice to the patient and clinician, patient for interpretation, online consultation, tutorial on how to use and correctly the point of care devices. And this is very important, especially for chronic diseases, then when more devices were developed, and for clinicians with different problematic interpretation of the new test, and to support on a correct decision on which test to apply. We spoke about apps for algorithms for interpreting results. I've just made a search on PubMed with this text, and I observed 42 papers, and none of them was regarding interpretation of laboratory tests, but this is some that will develop, and I think that we have to play our role in validating this. And finally, a more technical role. We already do something similar for controlling blood gas analyzers or glucose meters inside the hospital. And I think that this will be something that could be developed towards all the kind of point of care testing also in outside the hospitals, and we can use this way to control the quality of the results provided. So to conclude, with the necessary premise that nothing is so difficult as predicting the future, I reply, yes, there will be a classical role for the clinical lab in the future, even if there will be some important modification, and I think that part of the large production will move outside the lab toward, and the lab will develop more high technology level analytical devices, and will manage clinical information and control of the quality produced outside in the centralized settings. I have to thank some friends for some advice and some discussion, from Maurizio, Giuseppe, Michele Musa, Mario Plebani, and obviously Michael Neumeier, and thank you for your attention.